Thank you.
Yeah, this is a big parking garage, but yeah. So we have several things here. We do other types of training on other types of cranes. This would be typical of a small overhead crane you would find in a shop, inside shop. It's called a gantry crane. It's electric chain operated, but you could put anything on that that you wanted to. When we do our rigging training, these are 3 typical loads. They have to estimate the weight of this bundle, and then they have to rig it, and the sling hitch that they use has to be designed to contain a bundled load so that it's safe. Picking up the pipe, same way. Now we use the pipe, interesting. We have CIC, the accrediting agency, sponsors a national skills competition between cranes. We used to call it a rodeo, and somebody decided you can't call it a rodeo because you can't operate cranes electric. Anyway, but this pipe is part of it. They have to upright the pipe, which is no easy trick, because if you just hoist, the end of it will slide. So you've got this, again, there is a technique for doing it. Then you got to take it someplace and put it back down. Here we lift it up flat, and of course rigging that's no easy trick because the slings don't want to grip it and so forth. Tank, an old step gas tank full of sand, a representative of an offset center of gravity. It's heavier in that back end than the front end. It's got 2 different levels for sling mounting, so we get into sling adjustment, we get into leveling the load and so forth. Okay? So we're set up there. The boom truck, again, a little bit bigger, but it is just a telescoping boom crane. It is computerized. Okay? Some of the paraphernalia that you see on it is stuff that we set up for the CIC practical examination. It's a skills exam. So they have to navigate certain courses on the clock without hitting things, knocking things over, and so forth. Okay? Now, Jim has already told you, now these blocks really weren't designed for this crane, unfortunately, but this is typical of the kind of stuff that you're going to need if you're going to get off of the hard pad, or even on the hard. If I were to set this crane up in our parking lot, I would have those there, because these are going to cut nice, neat little square holes, because that parking lot's designed to support light cars and trucks, not a crane. So again, we're putting thousands of pounds per square inch. The larger circular ones over here, you see how quickly, where are they? Back over here, we had a 60-ton crane at one time. That's the minimum, okay, support for a 60-ton crane. Now that's considering that the ground, again, and they go up from there. There are rules of thumb. Now, our yard was compacted for cranes. This was put in layers, and they ran the thumper over it, again, that roller, and they pounded it for weeks. You cannot even drive a nail or spike. If you try to drive a 6-inch spike in there, it'll bend. So we don't really need, but you don't have that. The average job site, the ground's been disturbed, they've excavated, they've poured a pad. When you pour in, you're going to be on unimproved ground. You're going to be in yards and streets. You got to have curbs. Figure out how much cement do you have on a sidewalk, what's in the curb. Again, they're intended for different purposes. Okay,
so you can't afford to put something on there and crack and give way for the crane to tilt. And
it's the level of the crane. The crane's a precision machine, okay, or device. It has to be level within 1% grade, so the load chart's valid. That's less than 0.6 of a degree. Okay, it's amazing. I had a legal case, and this engineer from an engineering company came in, and his report said, well, the ground wasn't sufficiently disturbed to have turned the crane over. And the lawyer said, here's this big firm, are you going to just, I said, where's their reference date? I said, we're not building a road, we're not building a bridge, we're not building a building. Do they know how level it has to be? I don't see that anywhere in here, right? And then I went on to show them, had my 18-year-old grandson calculate for every inch of change, and we're talking about a very long boom, how much the radius changed and how much the capacity changed. Okay, didn't take much, about 3 inches at the boom length and the reach that they had to be out of whack.
They saw the monument in Wilmington, North Carolina.
Yes, wasn't that
that
was rodeo, wasn't it? Yeah.
The problem was when the monument cleared the ground, the boom deflected, the radius increased, and then he went right into the power line. You saw that?
Yeah, I saw that.
I mean, what we teach here is fundamentals at the basic level, fundamentals of load control. Now, there are certain, I call them givens. They're laws of physics. We can't deny it. Crane booms aren't totally rigid. We don't want to build them that big. So what's going to happen is, like your fishing rod, when you catch a fish, it's going to deflect. So the load's going to move. Okay. When you swing, and for those of you that work with a crane today, when you swing, which is the fastest movement on a crane, the boom moves before the ball does, or the load. There's no hard connection between the two. And the faster you move, the farther behind it gets, and then it's got to catch up. Now we have load swing. And loads are unforgiving. They're going to run into things. They'll kill you. They'll break your leg. They'll, knock holes in buildings and so on. So you need to control that load movement. The first key is smooth control movements. Don't get in a hurry. Cranes nowadays have what they call proportional controls. The speed is in the control. The farther I push it, the faster it goes. So I bring my RPM up to give me full flow in the pump, give me maximum use of my hydraulic system, and then I crack the valve to get it moving. Now I can start accelerating. Okay, it's not a drag race. Okay, so you want to start out nice and easy, and then you want to move into it depending on how far you want to go. And then there's techniques for canceling load. Again, we don't need to get into all of that. Okay.
Does this have a front stabilizer on it?
It does not.
Jack?
No,
It does not. So this has 180 degrees of operation from here on back. Has no capacity over the front. Might not even have it even if it had a front stabilizer there. So again, the rules for craning and the rules for reading the instructions are just so varied. The only thing you know with absolute certainty about your crane is what your chart says. If you get out of one crane and get in another crane and assume, the definition of assume that the rules are the same, that's where you could make a fatal mistake. The rules, the basics are the same, but there's little quirks, there's little features that crane manufacturers put in the crane to induce you to buy their crane as opposed to the other guys, because they all have a 30 ton, right? So what does my 30 ton do that yours doesn't? Okay.
Is that the chart there that you're talking about?
Mm-hmm.
By the controls?
Yes, that is the load chart or capacity chart for the crane itself. That's the operator station. It's pretty neat because everything is right there that you need. The controls, the throttle, the load chart, the computer, and we have what this is known as the street side control. We actually have a curbside control, which is on the other side. So the operator can go on the side to give them the best visibility of the load that they're lifting. Unfortunately, it also puts them under the boom, and under the truck if they turn it over. But they're not supposed to. Yeah, a good operator will not turn the crane over. Won't even have a conversation about it. It's not.
You don't
within,
talk about that.
It's not within the realm of possibility. Okay. Now we do two things here. We do rigging training where they have to put together a rigging plan to be able to lift those loads, and then we discuss the plan, critique it. Then they come out here and they have to develop the plan with available rigging, and you can see we've got a bunch of stuff here, and then they have to go and do it. Okay.
This is not stuff you'd want to use, some of that.
No. Some of it came out of the Crosby test lab. This actually came out of the real world. A lot of the others Crosby gave us, where they mashed and bashed and bent it and broke it in their test labs to see how strong it is. We do rigging inspection practical exams here. Much like the old biology exams that we used to do in school. Each station has a component at it, has a inspection sheet and calipers, necessary tools, and so on, so they're supposed to identify it. So we line them up across here, and when they finish theirs, they wait for an open station, but ultimately each one will have all 10. Then we go back into the classroom, and we talk about what did you find, okay? How did you look at it? What standard did you apply? Because to know whether something is good or bad in our business, it's not your opinion, it's not your best guess. It's what do the standards say. If it's not quantifiable and measurable, it has a very little value, okay, for sure. What we were talking about in the classroom was this type. We have two types of synthetic slings. We have the woven or flat strap. Now the limitation